Rockfalls and boulder encroachment are a significant risk to the railway, especially as we have more volatile seasonal weather patterns and the effects of climate change.
Basically, if a catch fence being hit by a rockfall, it may maintain the first impact, but the second impact will be the dangerous one because the system already being detected. Visual inspection is the main method being used to inspect the catch fences. This method is ineffective and also is very costly because you need to top the surfaces and get people on the track, which pose some risk on the inspectors.
We've developed a system which can be retrofitted to existing fence lines or a wholly new system. The system is innovative in that it helps to detect boulders and rockfall encroachment to within a 1 metre pinpoint area. So that means that by identifying where these have occurred, we can send people out to site to review that, or we can view it remotely with the use of additional cameras, and it helps to identify locations quicker with more accuracy.
So the system consists of two main components, a processing unit and a sensing cable. Processing unit works like a radar system. It sends signals through the cable. If the cable gets hit by a rock or being cut, it's reflected back the signal into the processing unit. The processing unit will then process that signal to locate the exact location and whether that impact is over a predefined set of levels. And then the data will be pushed into a data logger with CCTV cameras. The platform we've used, it's called Rail Alert. It's already been used by Network Rail. That system will notify members of Network Rail. The notification is going to be through emails, SMS messages with a link to evaluate the situation and take an action. Each processing unit can monitor 400 meter long of catch fence. We could combine multiple systems, so we could cover a large area with multiple sensors. The system have the ability to be interconnected, so all goes through the same channels.
We've now had a trial set up for about the last 12 months. The purpose of that was to see how it works, to test it for seasonal variations, the geography that it sits in, so that we can understand the implications of the system and things like the battery usage, power usage. We have taken a lot of data out of that to refine the system, and the next stage will be to understand that in a real world example.
We also use this trial to fine-tune the detection level because we try to minimize the false alert. For example, if the catch fence being moved by a strong wind or animals.
If the sensing cable is damaged, the whole system's been designed in a way that requires minimal hand tools, and where maintenance is required, it requires very little time and effort to do those repairs.
At the moment, it's going to be powered with batteries backed up by solar panels. The solar power will be enough to take it through the winter time.
The ethos behind the development of this system is that it can be rolled out en masse across the network where possible. It is a cheaper alternative to other means of detection, but not only that, you can get significant lengths of up to 400 metres for the one system set up. I would encourage anyone who's viewing this video and wants to know more about the system, please come and speak to us. We can happily showcase this system, explain the benefits and the technical side of how it works, and we would be delighted to show the system in more detail.